NASA's OSIRIS-REx mission has successfully returned samples from asteroid Bennu, providing key insights into the building blocks of life and the early solar system. The initial analysis of the material reveals a rich composition of organic molecules, amino acids, and water-altered minerals, supporting the theory that asteroids like Bennu may have played a role in delivering life-essential ingredients to Earth. Scientists identified 14 of the 20 amino acids necessary for building proteins in life on Earth. Amino acids are the fundamental components of proteins, which drive biological processes. Additionally, all 5 nucleobases, adenine, guanine, cytosine, thymine, and uracil, necessary for DNA and RNA, were found in the sample. This supports the idea that the raw materials for life could have arrived on Earth via asteroid impacts. The sample contains calcite and halite, minerals that typically form in the presence of water. This suggests that Bennu, or its parent body, had liquid water at some point in its history. This aligns with the hypothesis that water-rich asteroids may have contributed to Earth's early water supply. Bennu's material is rich in carbon, a key element for organic chemistry and life. The presence of carbon-based compounds reinforces theories that carbonaceous asteroids played a role in prebiotic chemistry, possibly leading to the formation of life on Earth. The presence of life's essential molecules on Bennu strengthens the idea that asteroids may have delivered these components to Earth billions of years ago. Studying Bennu helps scientists understand how the solar system evolved and how materials were distributed across different celestial bodies. The findings from Bennu will guide future asteroid sample return missions, including NASA's Dragonfly mission to Saturn's moon Titan, where similar organic processes might be occurring. NASA continues to analyze the samples, with further discoveries expected as new techniques are applied. The data from Bennu could reshape our understanding of how life emerged and how asteroid material influenced planetary evolution. For a more detailed overview, you can click on the link in the comment section.